For decades, astronomers believed the mystery at the center of our galaxy had already been solved. Every star racing around an invisible point seemed to tell the same story. A gigantic black hole was hiding there. Then a new analysis arrived with an unsettling implication. What if the object anchoring the Milky Way isn't a black hole at all? What if the strongest source of gravity in our galaxy is something even stranger? Suddenly, one of astronomy's most confident conclusions became an open question again. And if that question is answered the wrong way, it wouldn't just change our picture of the Milky Way, it could force physicists to rethink what happens when matter reaches its ultimate limits. The story begins nearly a century ago. In the 1930s, faint radio waves drifted toward Earth from the direction of the constellation Sagittarius. No telescope could reveal their source. Hidden behind dense clouds of interstellar dust, the galaxy's center remained stubbornly invisible. Astronomers were chasing whispers instead of answers. Those whispers slowly became patterns. Then the stars themselves began revealing something impossible. As instruments improved, scientists discovered stars whipping around an apparently empty region of space at extraordinary speeds, as though orbiting an object millions of times more massive than the Sun. The evidence seemed overwhelming, but one question refused to disappear. Were they seeing a black hole, or simply the gravity of something else entirely? The confidence in the black hole explanation came from remarkable precision. By tracking a star called S2, astronomers calculated that more than 4 million suns worth of mass was packed into a region smaller than the orbit of Venus. It was an extraordinary result. Yet one detail continued bothering some researchers. The measurements proved that something incredibly massive was there, but they did not directly prove the existence of an event horizon. That distinction matters. So scientists began testing a radical possibility. Could an ultra-dense core of dark matter create the same gravitational fingerprints? When the simulations were compared with the motions of stars near the galactic center, the outcome was startling. The alternative model reproduced the observations almost perfectly. If that sounds impossible, it should, because the explanation depends on a form of matter humanity has never directly detected. Imagine dark matter behaving unlike anything we've ever seen. Instead of collapsing forever, quantum physics may force its particles to resist being squeezed together. That invisible pressure could create a compact object with enormous gravity, one capable of guiding nearby stars exactly as a black hole would, yet without an event horizon, and the idea becomes even stranger. In this model, the dense core would not be separate from the Milky Way's dark matter halo. It would be the center of the same vast structure that surrounds our galaxy. If true, two of physics' greatest mysteries, the nature of dark matter and the nature of the object at the heart of the Milky Way, might be different pieces of the same puzzle. For now, the evidence still favors a supermassive black hole, and no observation has overturned that conclusion. But science has never advanced by protecting certainty. It advances by testing it. Over the coming decades, new observatories may finally search for the subtle signatures that only a true event horizon can produce, while next-generation dark matter experiments hunt for particles that have remained hidden for nearly a century. Somewhere between those discoveries lies the answer. If the familiar picture survives, our understanding of black holes will grow stronger than ever. But if it doesn't, the revelation will reach far beyond the Milky Way, reminding us that even after centuries of exploration, the universe can still hide its greatest truths in the place we thought we understood best.